Number 1, it tells us that ray DF bisects the angle. So whenever something is bisected, we know that it cuts it into two congruent parts. So we can see we have the two expressions for EF and FG here. And we know that those are equal because they are congruent. So 11x equals 6x plus 100. We will need to subtract 6x from both sides. That's going to give us 5x equals 100. And then divide both sides by 5, or x equals 20. Number 2, we are given that G is the centroid of the triangle, which that's where all of the medians intersect at. They tell me that the entire segment from B to E is 12, right? And so what they want are the two pieces of that segment. The rule was it was a 2-to-1 ratio, or it was cut into thirds. So I'm just going to take the entire length of the segment, divide it by 3, and that's going to actually give me the length of the smaller piece of that segment. So from B to G would be 4, which means that would leave from G to E to be 8, because again the entire length was 12. Number 3, where we're using the sum of the interior the interior angles of a polygon formula. So n minus 2 times 180 was the formula. Of course, n is the number of sides here, so 39. So this would be 39 minus 2 times 180. I believe this was the one with a nice answer. Oops. Yes, the correct answer would be 6,660 degrees. That would be the sum of the 39 angles. Where on number 4, they're asking for the measure of one interior angle rather than the sum. So I'm going to do the same formula. This time it would be 16 minus 2 times 180. Which is 2,520. So that would be the sum of all 16 angles. I just need one, so I would divide that by 16. Excuse me. So one of the angles would be 157.5 degrees. And that was number 4. Number 5 is a kite. I can see that because it's showing me that the adjacent sides are congruent. It gives me the angle R is 150 and the angle S is 90. And since we know it's a kite, we know that also angle U would be 90 as well, right? Those opposite angles right there are congruent to each other. My job is to find the measure of angle T. It is a quadrilateral, which means that the four angles do add up to 360. So if I added the given angles, I'm going to get 330. And then, of course, you're just going to find the difference. So that means that the measure of angle T would be 30 degrees. Number 6, this is a mid-segment, which means these two are congruent and these two are congruent. They give me the top is 53, one of the parallel sides, and the bottom was 114. And they're asking for the length of the mid-segment. It is the average of the two, so you're just going to do 53 plus 114 and divide that by 2. And I get 83.5, so LM is 83.5. Number 7 is a parallelogram. They give me that CDA is 85 degrees. They want me to find the measure of angle BCD, which is adjacent, and adjacent angles in parallelograms are supplementary. So I'm just going to do 180 minus 85. So the measure of angle BCD is 95 degrees. Number 8, this is a rectangle. What they do is they give me the two diagonal lengths, and they want me to find the value of x in a rectangle. Diagonals are congruent to each other, which means that 2x plus 29 is going to equal 39. And I just end up with a two-step equation to solve, so I'll be subtracting 29 from both sides. So you get 2x is 10, then divide by 2. I don't know why I drew that line right there. So the value of x is 5. Number 9 is a rhombus. Angle 1 is 140, and they're asking for the measure of angles 2 and 3. Angle 2 would also have to be 140, because in a rhombus, opposite angles are congruent. And then we can see here that one of the diagonals is drawn, which cuts the rhombus into two isosceles triangles. So if this is 140, then I know that these two angles here would be the base angles of that isosceles triangle. So I would have to just find them using the fact that I know the sum of the angles in a triangle is 180. So these two have to add up to 40, and then divide that by 2. So the measure of angle 3 would have to be 20 degrees. Number 10, polygons are similar, so that means they're proportional. We talked about how in class there's a lot of different ways to write this correctly. You do the way that makes most sense to you. For me, I would do 12 over 58, right? And I know that this and this correspond, right? The 12 is the little version of the 58, and so 3 and x would go together. So you're going to cross multiply. 12x is 58 times 3, it's 174, and then divide that by 12, and so that missing side is 14.5. Number 10 is also a proportion. They just don't have the picture drawn for me. They do have a diagram of a landscape plan that tells me that the scale is 1 to 10. So I can write a proportion in this one. If you can do this one without writing a proportion, that's really cool too. But 1 centimeter for every 10 feet. And they give me on the diagram, the trees are 4.1 centimeters apart. I want to know how many feet apart they are. So that's how I could possibly set that one up. Again, cross multiplying on this one, you're going to get x equals 41, and in this case, that would be feet. Number 12, this is the geometric mean, because we're finding the altitude of a right triangle from the right angle. We did write our little formula down for this one, so go back and look at that one. It's going to be the two segments that the hypotenuse is cut into, along with y, right? The geometric mean, we talked about why that worked. So that's how we're going to set it up. We are going to cross multiply again on this one. We get y squared equals 52. Let's go ahead and, find the decimal approximation for this one. I would have to take the square root of both sides, of course, because it is y squared. So y is going to equal approximately 7.2. And that's number 12. Since it didn't specify rounding to the nearest tenth, it's fine. And that's where we went with it. Number 13 is also proportional. Anytime that we have parallel lines and triangles like that, we know that it's broken up into proportions. Again, I feel like some of you guys could do this one in your head, but to be on the safe side, let's go ahead and write the proportion. These two correspond and these two correspond, right? So 7 over 21 equals x over 12. So I get 21x equals 84. If I divide by 21, I get the value of x is 4. That's number 13. Number 14 is also a proportion because it shows us here that this angle is being bisected. So that means that the triangle is also cut into proportional pieces. So x over 8.9 would correspond with 11.7 over 6.2. Again, make sure and keep your stuff consistent. All right, so if I cross multiply here, I get 6.2x equals, and 8.9 times 11.7 is 104.13. We get a not nice decimal for this one. Divide both sides by 6.2. The value of x here is 16.8. Whenever I rounded, I did have to round that one. Number 15 and 16 are both the Pythagorean theorem. Notice on this one we want to leave our answer in simplest radical form. So if I call my hypotenuse x in this one, it's just going to be 8 squared plus 10 squared is x squared. And we get 2 on the square root of 41. Right, because, let me go back. Because we do get 164, right, as x squared. And of course I want to take the square root of both sides, right? So if I take the square root of both sides, this one does reduce to 2 on the square root of 41. So that's the solution for number 15. Number 16, we're looking for a leg. So I'll be subtracting on this one because the hypotenuse is 19. So I will be subtracting 16 squared from both sides. So 19 squared minus 16 squared is 105. Now this time whenever I go to do the square root on both sides, the square root of 105 doesn't reduce. So your answer is just the square root of 105 because again we are asked to leave the answer in simplest radical form. All right, 17, 18, and 19 are SOHCAHTOA problems. Oops, my brain's getting ahead of my hand. Okay, so for this one, here we're given this angle. 5 is across from it, so it would be the opposite, and x is next to the given angle, so that would be adjacent. That means this is a tangent problem. The tangent of 20 degrees is the opposite over the adjacent. I am solving for x on this one, so I will multiply both sides times x. So I get x times the tangent of 20 is 5, right? These two divide out, I get 5. And then I would divide both sides by the tangent of 20. So 5. Remember, you're going to need to check your calculator's mode on this one. It should be in degree mode, but just to be on the safe side, I would check it. Again, these two are going to divide out. You get x equals 13.7, rounded to the nearest tenth. So that's the value of that leg, 13.7. That picture is very much not to scale. All right, so on this one, we're given this angle. 15 is the hypotenuse. X is the adjacent, right? It's right next to it. So this one's going to be the cosine of 36. Adjacent over hypotenuse would be x over 15. This one is just multiplication because you're looking for x, right? So just going to multiply here. So 15 times the cosine of 36. Oops. Wrong button on my calculator. 12.1. So x is 12.1. Again, these two divide out. And that is the length of the leg on number 18. Number 19 is very similar. Again, here's my angle. This time 20 is the hypotenuse, and x is across from the 32, so it would be the opposite. So that means this one's going to be sine. So the sine of 32 is the opposite over the hypotenuse. So kind of like the last one, and I'm going to need to multiply both sides times 20. So I'm going to do 20 times the sine of 32 is 10.6. So x would be 10.6. Okay, number 20 is also a SOHCAHTOA problem. However, notice for this one, we're finding an angle. So our last step with the calculator is going to be a little bit different. Now, I am looking for this angle, and 15 is the hypotenuse, and 12 is the adjacent. So I know it's going to be cosine, but now I don't have an angle to put behind it. So it's going to be the cosine of x is the adjacent over the hypotenuse. So if you remember, on your calculator, above the cosine in green is a button that is the inverse cosine, right? So that's anytime you're looking for an angle, you have to use the inverse. So I'm going to do the inverse cosine of 12 over 15. All right, let's see. Cosine, it would help if I used the correct button. You get 36, what does it say? Round to the nearest degree. Okay, so that's a whole number. So that'll be 37. So x is 37 degrees. Again, use your calculator. And round there's whole number. All right, 21 is the law of sines. The law of sines says that if you have an angle and the side that's across from it, you're going to write those as a proportion, and hopefully, again, you wrote down those formulas. This particular one is going to be the sine of 38 over 57. And then I'm given angle B, but I'm looking for side B, correct? So that's going to be the sine of 22 over B. And I just need to work that out, do a little bit of math. So cross multiplying here, I do get B times the sine of 38. And then 57 times the sine of 22. And I know that I'm going to have to divide by the sine of 38 on both sides, right? Because I'm trying to solve for B. So these two are going to cancel out. So B is going to be equal to 57 times the sine of 22 divided by the sine of 38. And I get 34 point, what are we rounding to? Okay, so I'm going to stick to the 10th, 34.7. 34.7. That's the law of sines. All right, 22. We are, okay, this is a typo. I know it says find the missing angle. It should not say that. We're actually finding the missing side here, you can see. So it should just say use the law of cosines to find the missing value. So we are not looking for an angle in this one. We are looking for a side. The law of cosines was the one that kind of looked like the Pythagorean theorem, if you recall. So I am looking for f, so we are going to start off with f squared equals. The other two sides, g and h, are 18 and 25. Remember, it doesn't matter the order that you use them as long as you're using both of them. Again, refer to your formula, please. It'll be 18 squared plus 25 squared minus 2 times 18 times 25 times the cosine of the angle that is across from the side that I'm looking for. So that would be 55. And this was the nice one, because I'm just going to put all of that in my calculator. 18 squared plus 25 squared minus 2 times 18 times 25 times the cosine of 55. And I get 432 point stuff. And obviously that's not the size of the side, right? The other two sides are 18 and 25. It's f squared, right? So what I'm going to do in my calculator is I'm going to tell it to find the square root of the answer, which I'm going to do right now. So the square root of the 432.78 stuff is approximately, again, rounding to the nearest whole number. Notice that's what it says, rounding the nearest whole number. Ooh, I hate that. It was just 21. So f is 21 feet. Let's fix that because it is feet. 21 feet. Well, that answer makes a whole lot more sense than 432. All right, number 23. I am going to have to graph this one. Do I have graph paper? I don't have graph paper. Give me a second. Let me add a page. And put my graph on it. Okay, go away. Now, you don't have to graph this one. I'm not going to check to see that you graph it. It just helps with the visual because you're trying to decide if it's isosceles, scalene, or right. That was the problem. All right, and then the 3 points were, J was -2 and 3. All right, so there's J. K is 1 and 6. 1, 1, 2, 3, 4, 5, 6. And then L was 5 and -1. 1, 2, 3, 4, 5 and -1 would be here. So hopefully it's obvious that this triangle is definitely not equilateral. It looks like it might possibly be isosceles, right? It looks like JL and KL might possibly be congruent to each other. So I'm going to use the distance formula, which again, hopefully you wrote down. So I'm going to find the distance from J to L first. It doesn't matter which one, just pick one. I should have written them down here. Let me do that real quick. It just helps me to be able to see them. That was 1 and 6, and this was 5 and -1. All right, so the two x values for J and L are -2 and 5. So -2 minus 5 squared. And then the two y values were 3 and -1. So 3 minus -1 squared. Please, 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 please be careful with your negative signs. Let's see, what 7 squared is 49. And 3, 4 of that 16. So that's the square root of 65. That's the length from J to L. If you want to find the decimal, great, but I'm not going to because I don't need to. And then from L to K, so right, we just figured out this was the square root of 65, which is a little bit more than 8. So I'm going to do the same thing from K to L. Oops, I forgot my equal sign. So K to L would be 1 minus 5 squared. And 6 minus -1 squared. So that's also going to give me the square root of 65. Okay, so since these two sides are congruent, we know that this is an isosceles triangle, which would actually be the correct answer for number 23. It's isosceles. Remember, the other two options were equilateral or scalene. Again, obviously not equilateral. And if these two had been different numbers, that means all three sides would have been different and it would have been scalene. All right, 24, AB is a tangent to the circle. So since it's tangent, we know that the radius and the tangent are perpendicular. So we know that's a right angle, which makes that a right triangle. My job is to find the length of the radius, and you can see how it's labeled right here. And AB is 5, and from A to O is 7.2. This is the Pythagorean theorem. So, not that we haven't done that 25 times this year. R squared plus 5 squared is 7.2 squared. We are looking for a leg. So I will be subtracting on this one. 7.2 squared minus... Okay, so I get... round to the nearest tenth, it's saying. So R would equal 5.2. That's just the Pythagorean theorem. That's number 24. And number 25. This is the inscribed angle theorem. The inscribed angle theorem said if you have the arc and you're looking for the inscribed angle, the angle is always half of the size of the arc. So all I have to do on this one is divide that by 2. And I don't trust myself to do that in my head. So that means x is 32 and a half. And that's it.